Today, we're proud to present the next evolution in Magento performance, Stratus MAS, with all the speed, scalability, and security of a SaaS platform, but specifically for Magento. Eliminate downtime due to traffic surges or code updates. Stratus MAS keeps your store online with proactive maintenance, protects your reputation with malware scanning made for Magento, and is backed by the strongest support team in the industry. We respond to support tickets in 15 minutes or less, day or night. Simple, session-based pricing too. That's Stratus MAS, Magento as a service.
Hey, welcome back, everybody, and thank you so much for hanging out with us today. From beginning to end, it has been jam-packed with some great content. Our next presentation is no exception. I'm proud to introduce Fahd Siddiqui. Fahd has served as the Senior Manager of SaaS Architecture at Magento, an Adobe company, and is currently leading data services. He worked in Cloudera, where he worked on Cloudera's SaaS products, such as Altus and Director. He has been fundamentally involved in creating EmoDB, an open source data store on top of Cassandra. His primary interests are in highly scalable and distributed systems. He holds a master's degree in computer engineering from the University of Texas at Austin, Hook'em Horns, and an MBA from Louisiana State University. Please welcome to our virtual stage, Fahd Siddiqui. Fahd, it's all yours, man.
Thanks, Shannon. So yeah, as Shannon mentioned, I'm Fahd Siddiqui, and here are a couple of places that you can catch me online. Would love to interact with if you have any questions. So basically, before talking and going right into gRPC and why we selected that as a communication protocol for our storefront services, I would like to take a step back and kind of talk about a little bit on what led us to even think about communication protocols. What was missing? Why, go back to the drawing board and think about it. And then I would like to talk a little bit about our SaaS-based services or Magento data services. Some of the products you may or may not have heard of, like product recommendations, live search, channels, and MBI, to name a few. And then also we'll get into why we decided on converging on gRPC. So a little bit of history before that. On November 17, 2015, I do want to give a disclaimer before that all these dates are approximations, and if there are some glaring mistakes in it, you can feel free to blame Igor Minialov, our chief architect, who told me these things. Anyway, so Magento 2.0 is released, and one of the pain points of Magento 1.0 was it was basically based on inheritance, which was not uncommon for the web applications of that time. And the problem with that is, for customization, for third-party customizations, it meant that none of our methods could be private. It has to be the public and protected, which implies that anybody can change anything. It's good for customization, and that is definitely one of the key features which we still hold very dear to us is extensibility. But at the same time, that raised the total cost of ownership when it comes to things like adding a new extension or having conflicting data structures or even doing a simple upgrade. So that's what Magento 2.0 came in, and one of the key features was that it changed inheritance to composition. However, the thing that is more related to this talk is that it also introduced service contracts. One of the things about those service contracts was that the service contract were mostly back office oriented. So think CRUD type features for things like CRM or PIM, adding a product, deleting a product, things like that. And then the web services would call these service contracts and which again were mostly back office oriented. And unfortunately, there were still, and it still does, there are some tightly integration that exists between modules that don't go through service contracts. So around 2016 or early 2017, the use case for headless Magento arrives, and also PWA makes a big entrance, which makes it clear that that there needs to be a focus on API that is shopper facing and not just for the back office related API. And so in order to support headless and PWA, REST had a grave problem. And one of that problem is that over HTTP 1.x protocol, each call takes a dedicated HTTP connection, which meant that in order to fulfill a storefront page, you had to make several calls to paint that page, to render that page. And that was a performance issue. As you know, if only there was something that wouldn't require too many calls and retrieve all the data that a particular storefront page needed, that would be great. And with that, what we saw was GraphQL. So now in Magento 2.3.x, we do have GraphQL resolvers. We have a storefront gateway. However, that kind of solved the last mile problem a little bit, which is between the storefront page and the GraphQL. So yes, you don't have to, call disparate REST calls thousands of times to get all the data you need. You just need to make one call. You can construct your query, and you get all the data back. However, after that, behind the scene of GraphQL Gateway, the picture isn't so rosy because it still relies on the same service contracts, on the same admin panel that is that hurts us and is not very performant today. Which basically, at that point, we started thinking about service decomposition. And due to domain-driven design, it became fairly clear that there were two domains, in fact, not one. One is the storefront API domain, and then comes the back office domain. The storefront API domain is our storefront services that power our storefront pages, or PWA, if you will, or any other application, headless application for that matter. And then there was the back office. In the back office, if you think about enterprise clients, it could be things like PIM or CRM or inventory management that people bring to the table. So it's kind of like bring your own back office components, and we should be able to integrate it fairly easily with our storefront API. And this is what our future or plan of the record is, by the way. So now, if I take a derivative of this diagram and kind of double click on that, it will take me here where any generic service will look somewhat like this. So you'll have your Magento monolith, the user comes in, and the service contract, which are PHP interface, have a choice. They can either go to an existing implementation, or they can go to a service implementation from GraphQL server. And we plan on this. This is not there yet, but this is what the teams are working on. And just a quick plug on community hangouts, where they have given a few presentations and the sneak peeks on what we are working on. So that is where the standalone GraphQL comes in. And the purpose of this standalone GraphQL is to provide an API facade, which is a really great way to make incremental progress. So for example, if we were to release just the catalog of storefront first, which means not having a big bang approach, just one quick catalog of storefront service, we would be able to do that and introduce it here so that anything related to catalog of storefront service can utilize the new service, whereas for the others, they can still go back to the existing monolith. And that takes me to our move to SaaS-based extensions. So as I mentioned earlier, all our data solution extensions are SaaS-based. So if you're looking at product recommendation, or if you have had experience with product recommendation or intelligent product recommendation solution, or channels, or one of the new things that we're working on, which is search. I think we're already in alpha, but it'll be out for GA next year, sometime next year. And those are all SaaS-based extensions. So why did we go SaaS instead of our regular extension? So a lot of reasons, but the salient reasons are it reduces your total cost of ownership, which means it's a better client upgrade experience, not only from the backend. So it's not just that we have our extension, but our backend is all SaaS, which is great. But even on the UI side, we have made it into a React app. So a lot of security or patches can be done from our end, and there's no action required from the consumer or the SI who's maintaining that Magento instance. And of course, that provides us a pretty robust and maintainable solution. So again, so as I said, Magento Data Services is offered as a SaaS-based extension, and it fits very nicely with Magento's future vision, which if you have attended Igor's talk earlier this morning or some of the other talks, you are already familiar with this 30,000 feet overview. In this talk, I'll talk about integration with SaaS service, which is represented here in this diagram. We double click on that. And here, I just want to mention quickly, the focus here is, so if you look at the left-hand side, you have your Magento instance, you have a services connector that then goes into our SaaS services. And there are various components to it. Of course, we have an API gateway, Adobe IO Gateway, that takes care of validation, authentication, routing. The part that we are concerned about here in this talk is this part. So we have these microservices architecture, right? And a part of microservices is that our service graph is going to expand quite a bit. There will be platform level services and storefront public facing services themselves are pretty large. So when we're talking about these edge to edge scenarios, communication protocol becomes really important. And we can't, and there are two things to it. Number one, that we have performance is paramount in this case. And the second thing is we do have flexibility in choosing the technology, right? So there could be something that is not very mature when you think about it from browser's perspective. But since we are in our closed world, we have freedom to choose something that is the most performant technology that makes sense for us. So with that, communication protocol matters. So if you think why we couldn't implement microservices architecture in the early 2000s is because the cost was too high. You couldn't imagine exploding a monolith application into thousands of microservices and then sending megabytes of XML files around so that it could be serialized, deserialized. The cost would have been too high. CPU cost would have been too high. Having said that, we cannot lose sight of that because serialization, deserialization cost is real. Wire transfer cost is real. So if you can think of even JSON textual files, if you're moving it around the wire, that can get pretty bloated. And then the last two the last one is more like a requirement, which is platform independence. It would be nice to, have a service in Go and not have to change everything. It would be nice to have a service in Kotlin or Java. And then the third bullet there is more of it's also a requirement, backward and forward compatibility, but also offers a quality of life improvement and in having more stable solutions. So that actually led us to the question, what communication protocol should we standardize around for our services, for our storefront services? And I can't actually, in the interest of time, go over all these different aspects, but we have to look at it from a point of view that if your service graph is really large, then what are demands of such a service graph? There are easy API management, there are observability, performance, security, extensibility. We're going to look at these three demands, which is easy API management, performance, and then extensibility. So I'm going to assume that you guys are familiar with REST and GraphQL. At least a rudimentary knowledge is there. So let's talk about gRPC a little bit. A gRPC is basically a high-performance open-source RPC framework developed by Google. It's been around for a while, and it has been accepted by CNCF as an RPC framework for building cloud-native apps. Everything about gRPC from ground up has been about performance. So performance is paramount above all, but it's just not about performance. It actually came up to be a better design for RPC framework and a better way of creating distributed systems application as well. And as I said, it is platform independent. All right, that's cool, but what's new? I mean, REST is platform independent. One of the main things, I mean, there are several things, but if you want to take out, I just picked the most important things that made our decision. So unlike REST, streaming is a core method of communication. And anybody who has had enough experience with REST knows that whenever you're trying to, let's say, send back thousands of products or thousands of search results back, you either have to do paging or you have to maintain a long living connection by sending heartbeats and stuff like that. Well, streaming is native to gRPC that even the most simplest call, which is the unary call, it's basically a synchronous hello world call, is also based on streaming when you're talking gRPC. It's just the only difference is that the header, the HTTP header that they send over, has only one packet, and that's about it. And based on this streaming pattern, they have their all four types of communication patterns of gRPC, which is unary, bidirectional streaming, client-side streaming, and server streaming. Also, and I kind of mentioned the second point, it's not limited to request response model of HTTP 1.x. It is based on HTTP 2.0, which gives a lot of performance improvement, primarily that you can use the same connection for multiple requests. And finally, last but certainly not the least, that it uses a protocol called protocol buffer, or Protobuf for short, which is based on binary serialization and is a strongly typed protocol. So you can actually say this is what the type of your attribute is. Some of the main differences between gRPC and REST are as follows. May not go through all of that, and I'm probably already talked about three of the top ones there. Performance, clear winner. REST. By the way, quick note on performance. So we had long discussions about it because remember, if you are going to adopt a new technology, you better be sure that it is needed and that investment is called for, right? So I'm going to go ahead and claim that, yes, you can actually probably have comparable performance with REST and JSON because you can definitely use HTTP 2 for REST and JSON. There's nothing in the specification that calls for not using, HTTP 2. And you can definitely have compression on JSON. And we did a performance test, and gRPC wins even then, and I'll get into that in a minute. With that, let's talk about easy API management for a second. So Proto compiler, first of all, Protobuf as a specification is very concise way of specifying your contract, your API RPC contract. And there's not very many chances of error. It's not very complicated at all. And then there are these proto compilers that are available for upwards of 9 languages. And based on these proto files, the compiler does not only generate client-side, but also server-side stubbing for any language, or for those 9 or 10 languages that that are already supported. And so all that is required for you is to share proto files with your consumers, and you don't really have to maintain client SDK. So this kind of helps you when you're creating Storefront services, and also helps us on the SaaS side, some of the lessons that we have learned. You can obviously, for whatever reason, you may want to create these packages, SDK packages. There's no harm in doing that, but yeah, you don't have to. Quickly going to talk about anatomy of a protocol buffer, because this is going to show us why this gives us backward and forward compatibility. So of course, as you can imagine, there is your field types, and this is what brings us type safety. It can be a scalar type or any other message type. So you can create another message, and you can also reference it over here. This numbers that you see on the right-hand side are very important. They're called field number. You should not reuse this. And the reason for that is these numbers is how a Protobuf message is encoded. So these are the order in which the Protobuf messages are going to send in. And if you, let's say in your newer version, you reuse the same number, the problem is you're going to break backward compatibility. So you shouldn't use those numbers. And then finally, you have your field name. Field name is of no importance to Protobuf, and that's a great thing because one of the two major challenges, as we know in computer science, is naming things. And here you can rename field as much as you want, and Proto really doesn't care because, as I mentioned, it just cares about the field number. And the only place where the name comes in is when you're deserializing the payload, the binary payload, and it hydrates your object. Finally, an example of a protocol buffer. So let's say on the top you have a message that has just one field, which is an integer. And I just noticed this is protocol buffer version 2 because in version 3, all fields are optional. So there's no optional keyword there. But basically, this is an integer, A. As I mentioned, it doesn't matter what you call it. And the field number is 1. It only takes 3 bytes to encode this message. There is an encoding document. If you had more time, you would have gotten into encoding and had a lot of fun and geeked out on that. And I would have asked the bonus question: is what value is in A, which is 150. We don't have time for that, so we're going to move on. Okay, so again, talking about dev experience, what does it require at a high level to implement a gRPC service? You have to define a protofile. This first step is of the utmost importance. And in fact, I recommend that the first PR or pull request should just contain the protofile. No implementation required, nothing, just protofile. Let the team look at that protofile, discuss that protofile, come back on it, because that is where the most important decisions are taken. In fact, I was talking to one of Google engineers who use Protobuf all over their services. And they say the senior the engineer is, the more time they spend in Protofile, which is not hard to believe. Then you can, it allows you to generate server and client stubs that I've already mentioned. So there's no manual step needed there. And then you override the generated server class to fill in your business logic. And if you're on the client side, you basically use the generated client stubs to invoke those functions. Basically, we talked about easy API management, and we kind of went through a quick overview of gRPC. Now, what about performance, also known as can I achieve the same performance with GraphQL/JSON? And this is actually exactly the question that Andrei Konosov, our architect, asked me, a few months ago, or was it 2019? 2020 is just a blur at this point. So we said, okay, let's see if we can do it, because theoretically, as I mentioned, you can use HTTP2, you can also compress it. Of course, even if I just want to say this here as a disclaimer, even if, let's say, you achieve the same performance, there are other reasons, as I mentioned, for gRPC that I think gRPC still makes a compelling case. But nevertheless, we did our homework, and it was a fun exercise. I want to give credit to Andrei Konosov here. We looked at that, and first, we just noticed in our things that we compared, there is no HTTP1 here at all, because we already know that's a done deal. I mean, if you're using HTTP1 and HTTP2, obviously gRPC is going to win, but it's probably going to win because it's using HTTP2. That's like saying you're using, comparing apples and oranges. So we took that out of the equation. We are using GraphQL and HTTP2, and then GraphQL, which also we kind of knew that gRPC will beat that because gRPC is compressed, and GraphQL, even on HTTP2, is going to use JSON, so it's not compressed. And then we also had HTTP2 compressed. So now you can see the light blue and the green, which is gRPC, are kind of close, but gRPC kind of ekes out a little better, right? And so I was like, hey, Andrei, see, I win. I mean, it's clearly good. And Andrei was still not convinced. And he was like, well, I think in some use cases, the payload may achieve better compression than gRPC would give us. And if that's the case, if deserialization is the only reason why gRPC is winning, then maybe I can do better. And he sure did another experiment where he went with a contrived payload. So in this, the difference between this and the first experiment is in this experiment, we purposefully came up with a payload that had a repeated, like same string that was repeated like 1,000 times, like hello, right? And the idea was that when you do that, chances are that your regular compression is going to compress it further, whereas gRPC is not doing compression. It's actually an encoding algorithm, right? Or encoding mechanism. So it's just doing zeros and ones, so it's going to just repeat that again and again and again. As you can see here, it actually did do better. By the way, it did a lot better than a regular gRPC. So which tells us that, yes, if you're using gRPC, go ahead and compress that payload if you can take a little hit on the performance, because uncompression would need some bandwidth. And then, however, even then, as you can see, gRPC kind of wins. I am going to call it because the deserialization is better when you're sending in binary and doing that instead of decompressing it and then deserializing it. But we can get close. Finally, I want to talk a little bit about extensibility. As you know, extensibility is very dear to Magento. Even when we're talking about SaaS services or decomposing this or that, we're always thinking about extensibility and how we can take, because that is something that allowed Magento to become a community, right? And so there are two levels to that in our new architecture. There's an extensibility in GraphQL schema, and then there's extensibility within the storefront behavior service. So if I can give an example, is extensibility in this schema is something where you want to add a new attribute, right? And the extensibility in the service behavior is if you want that service to and modify that behavior itself. So if I go back to this diagram, the GraphQL schema extensively is going to happen in the standalone GraphQL server layer, and we're not going to talk about it too much here. Andrew Levine is somebody who will give talks in our community hangout, and he's the expert in that. And then we actually propose to use extendable Protobuf messages. Remember the message that I just showed you, and how we can actually modify the core data structure themselves. And to do that, we're going to use this strategy of basically using repeated any type in Protobuf. So what any type is in Protobuf is that it allows you to embed a message without any predefined proto definition. So basically, it can allow you to send an arbitrary serialized message as just the bytes type over. So in other words, if we create a SaaS service and you want to modify that behavior of that SaaS service, you can send in whatever binary in that field to us, and we'll forward it to your remote function. And then your remote function, without knowing, you're just proxying the bytes over. And then your remote function can actually hydrate it back, or as gRPC terminology goes, unpack it into your Protobuf class. And so basically we get really deep level of extensibility around that. There are some patterns, and this is going to be my last slide for the talk. Some of the pattern, and of course, these are some of the good things that gRPC gives us, is Kubernetes and containerization has decreased the infrastructure complexity by an order of magnitude. So we should use that. We should create and codify our canonical deployments so that we're not reinventing the same thing again. Use Protos all the way. For your message types, you can bake in common functionality in gRPC interceptors, which we haven't talked about, but it's pretty cool. And that will scale go-to-market for your services. And with that, thank you very much for the opportunity. And if you have any questions, I'll take them now.
All right, Fahd, great job, man. You must have a sixth sense. You absolutely nailed the time on that. There's literally one question in the chat, and that is all the time that we will have for Q&A. And I'm going to throw it out to you now. Where do you find details on how the SaaS-based service layer works? For example, I see there's a sandbox API key, but I didn't find any use for that during my recent interaction with it.
Great question. So currently we do have sandbox API keys. However, we are still, I would say, in a very infancy of our SaaS journey. So all the SaaS services that we have in production today only allow you to use production API keys. But pretty soon we will be allowing sandbox environments, and so that will allow you to play with sandbox API. Right now, I think we're using sandbox API keys only for like internal development, and that's about it. But it's coming, so thank you for that. Thank you for playing around with the API portal in the sandbox. Yeah.
Fantastic. Thank you, Fahd Siddiqui. That was a wonderful presentation. Very grateful for that. It's time for me to give a shout out to my friends at Digital. Me, Magento New York, is proud to have Digital as a headline sponsor, the leader in omnichannel marketing automation technology, and is the platform of choice for businesses seeking to engage customers across all touch points. The platform's features empower 44,000 plus brands across 150 countries to acquire, convert, and retain customers. Check out their booth now. Visit all of your sponsors. Have a great break. We'll be back in about 30 minutes.